Electron configuration is the distribution of electrons in orbitals. So some example of these orbitals would be S, P, D, and F. S can hold up to 2 electrons, P can hold up to 6 electrons, D can hold up to 10 electrons, and F can hold up to 14 electrons. These orbitals have different energy levels. Energy levels is categorized as energy level 1, energy level 2, energy level 3, etc. So the farthest the orbitals are from the nucleus, the more energy they require. Therefore, if they are closer to the nucleus, the less energy required. Now, one way to do electron configuration is by using this pattern that we see here. Electron fills orbitals in a way to minimize the energy of an atom. Therefore, the electrons in an atom fill the principal energy orders in order to increase energy. So we start from the lowest level energy to the greatest level energy. What happens is like each level goes to the least one to the greatest. For example, 1s will go through S, 2p will go to 3s, okay, 3p will go to 4s, 3d will go to 4p, then 4p will go to 5s, 4d will go to 5p, 4f will go to 5d, 5f will go to sd. Let's do an example. Hydrogen has 1 electron and has also 1 energy level. Therefore, hydrogen will be 1s1. Remember that orbital s can hold up to 2 electrons, but because we don't need it, because hydrogen has only 1 electron, we just leave it like this, 1s1. Now let's do another example. Oxygen has 8 electrons. So we can start with our first energy level, will be 1s2, because S can hold up to 2 electrons. Then from 1s we go to 2s, so it will be 2s2. So we got 4 so far. And then we will go to P. Now P can hold up to 6 electrons. So we will fill P with 6. So we have 8 electrons in total. Now we can also do electron configuration by using the orbital diagram. So how do we do this? First, we pull up some dashes behind because each dash represents 1 orbital. So this will be 1s, this will be 2s, 2s, this would be 2p, and it would be 3s. So how do we write the orbital diagram? So instead of using numbers as we did to put, for example, 1s, that we use this number, we're going to use arrows. So for example, if we're going to write the orbital diagram of oxygen, it will be 1s2 to start. So we will have 2 arrows, but those arrows are like energy spins in opposite. So it will be one arrow like this and 1 arrow like that, in order to represent the 2 electrons. So 1s will be 1, 2, then 2s can also hold up to 2 electrons, so we have 2 spinning arrows, will be 1 and 2. But then with P, we cannot write 3s yet, because P can hold up to 6 electrons, so that means that we have to write P 2 more times, because it can hold up to 6 electrons, so it will be 2, 4, and 6. However, if according to Ohm's law, we cannot fill each orbital without filling the other one first. What I mean is, let's say oxygen has 8 electrons, right? So we have so far 4 here, so we need 4 more. So what we will do first will be 1, 2, 6. And then when we start filling this first, then we go to the first p orbital. It will be 7, 8. And this will be the orbital diagram of oxygen. 8 electrons.